Well, good afternoon, everyone. This is Barb Tyson, and I'd like to welcome you to today's Salty Dog webinar. With us today, we have Gino Morrelli of Morrelli and Melvin Design and Engineering. Gino is a noted multi-hull designer, and he will be presenting Choosing Your Cruising Multi-Hull. Before we get started, please remember to keep muted and keep your video off. That really does help those who have limited bandwidth. I have opened a chat box where you can type in any questions or any comments that you have for Gino today. And of course, we're going to record this webinar, and I'll send out a link to everyone who's registered so you can review it, or for those who can't join us live today, they'll be able to come back and watch this. And before we start the webinar, I'm going to hand things over to our Salty Dog Sailing Association President, Hank George.
Well, good afternoon, everyone. Thank you for dialing in, and thank you, Gino, for being with us. The famous boats that Gino and Gino Morrelli, Pete Melvin have had a hand in designing are amazing. The 2013 America's Cup Challenger Emirates Team New Zealand AC-72, the 2010 America's Cup winner Oracle BMW, 88 America's Cup winner Stars and Stripes Catamaran, 125-foot record-breaking Cat PlayStation, and more. Gino also extensively sailed on Stars and Stripes with Dennis Conner, PlayStation with Steve Fawcett, setting 12 world records. And Morrelli and Melvin Designs have won 20 Boat of the Year awards. So very impressive. Thank you again, Gino, for sharing your time and thoughts with us today.
Sure.
I'll turn it over to you. Take it away. Thank you.
Okay, great. Well, what we're going to cover today is basically kind of some basic parameters you might look at if you're thinking about choosing a cruising catamaran. And the first part of this presentation will be kind of some background on our company and kind of how we got to where we are after 30 odd years of messing around with boats and catamarans. This first picture is actually a boat called Mala Conducta. It was a custom 60-footer that we designed a few years back. And most of the catamarans we design are either custom, semi-custom, or we have done a lot of production work with Robertson and King. So the general mix of boats we've done have earned all kinds of awards. We've won America's Cup twice. We designed the NACRA 17, which is the current Olympic class catamaran. And as Hank said, we've won a number of Boat of the Year awards. One of the crazier boats we ever got to work on was the 2010 BMW Oracle America's Cup Trimaran. And this crazy boat, 130 something foot long, 200-foot rig, was capable of sailing at 4 times wind speed, which is almost like ice boat territory. That is comparison to the boat on the left, which was the original America's Cup yacht. So sailing has changed, and if anybody's watching the America's Cup on TV this week, it's gone one more step further. Our company is comprised of myself and my partner, Pete, and we started 30 odd years ago in my, which is kind of funny, in my house, in my spare bedroom, and that's back where I am again today with COVID. So we've closed our office in Newport Beach, and all 10 of our guys are all working from home. And frankly, I don't think we're ever going to get back into an office again because everyone likes working at home. But most of the guys are all degreed engineers of one type or another, a PhD and masters, a bunch of smart guys. I think I'm the only guy in the company without a degree behind his name. I kind of started in the catamaran business, basically sailing Hobie cats, and it was kind of the hobby that turned into the career. And one of my first big successes was being chosen to help design Stars and Stripes, the '88 America's Cup Defender with San Diego Yacht Club and Dennis Connors. And that was kind of my first introduction into America's Cup. And took us a while. We won on the water, but it took us a few more months to win in court. But this was in 1988, so it was quite a long time ago. But This boat wasn't too far from what was sailed in the America's Cup in San Francisco and Bermuda. Another picture of Oracle BMW. This boat, 90 foot wide, could fly the main hull in 6 knots of true wind speed. So it was a pretty powerful boat. And this is a shot of Team New Zealand, 2013 America's Cup boat that we helped design. And this was one of the first breakthrough boats that could actually fly. And since then, we've never turned back. And probably every 5th word in our office is foiling or hydrofoils or flying, all types, sailing cats, power cats. Not that we're ever going to fly a cruising cat, but we do use a lot of foil-assisted foils on cruising cats to help dampen pitching, which I'll briefly talk about later. This was a big 125 footer we designed for a man named Steve Fawcett, and eventually broke the around the world record, the transatlantic record, both directions, 24-hour records. I was fortunate to be able to crew on this boat extensively. And I have a crazy personal record of going across the Atlantic 5 times in 18 months as we were trying to break the Atlantic record. So it was back and forth from New York to England. So that was a lot of sea miles in a short period of time. These boats are more customary to what I imagine most of the audience is thinking about purchasing, which are production cruising catamarans. And we had the fortunate relationship with Robertson and Kane and Leopard series to design, I think we ended up designing about 10 boats for them over 10 years, from the Leopard 38 up through the Leopard 46. And working closely with Robertson Kane, and especially the Moorings company, the big charter company, we were able to learn quite a bit about what was important to day charter boats in particular, and cruising yachts in general. And that's kind of where our career our career path as designers went towards more and more cruising. Over the years, I think we've garnered now, I don't know, 25 or so Boat of the Year awards from everything from the HH catamarans that we currently design, through the Leopards, through the Gunboat series. And the Gunboat series was the line built in Cape Town originally. And that comprised of 4 or 5 models. And to date, we've designed over about 16,000 boats. But the boat at the top is the #1 winner at 15,000 wave catamarans. That's the Hobie Wave, that little plastic thing that you see strewn all over the beaches, all over the world in places like Club Meds and different resort areas. This is an example of one of our custom cruising cats. This is a boat, 65 footer, all carbon, built here in California. It's now called Gizmo, and it's out in the South Pacific. This is about a 6-year-old boat, 7-year-old boat. And it's been around the world once and a half already. It's a good example of a kind of a higher performance cruising catamaran. This is one of the nice interiors that was built for the MM60 Mala Conducta. This was built by Lyman Morris on the East Coast up in Maine about 6-7 years ago. Even though it looks like the veneers give the boat a really nice warm appearance, all these veneers are either 1 millimeter thick or 1.5 millimeters thick, laminated over foam or Nomex honeycomb. So even though it has this nice thick kind of solid appearance, it's actually very lightly constructed. One of the things about catamarans that's kind of interesting is that the boat builder only gets to build 40% of the weight of the boat. the bill of materials is 60% of the weight of the boat. The mast, the engines, the windows, the hardware, the sails, the anchors, the chain. So a lot of times people blame boat builders for boats being overweight, but a lot of times these days we really have to work hard with the suppliers to try to minimize the weight of the boat, because most of the decent builders are using infusion and some of the better boat building techniques, and all the low-hanging fruit is started to get torn out of even production boats these days. And it's always our job as designers to try to reduce the weight of the boat, because that increases the performance, the range, reduces the power required. And a lot of times now we have to work even closer with manufacturers of equipment to try to get them to reduce the weight of their product. So today, the basic outline for what I'm gonna cover are these 10 different design considerations. And we'll cover the size of boats, beam under wing clearance, transom clearance, sail area and safety, mini keels versus dagger boards, and a couple different types of dagger boards. Your interior choices typically include galley up versus galley down, and there's reasons for both. Number 7, hull volume, will kind of explain what you probably see in the marketplace is this trend towards reverse bows, what people refer to as wave piercing bows. And I'll explain some of the physics and the reasons behind that. Number 8 are the helm options, and catamarans have a lot of options, and you've probably seen a lot of choices. And we'll go through some of the pros and cons of various options that boat builders and designers choose. Number 9 is one of the very common questions we receive on a practically weekly basis, is the viability of diesel electric hybrids. And I'll expand on some of my personal preferences to that. And number 10 is electrical generation, which is kind of an overview of solar panel, hydro generators, et cetera. When we're looking at boats, we kind of break the boats down into these kind of 5 basic categories. And what we kind of think is a range for different people, considering how they want to cruise and whether they're thinking about going around the planet or just coastal. We kind of break down the range, operating range of the boat in these kind of lengths. So between 30 and 40 feet, that's a good, comfortable kind of coastal cruising size. And typically that boat is an owner operator. So we expect that the owner takes care of the boat, the owner manages all the work on the boat. And it might just be a single-handed guy, or it might be a couple, or it might be a skipper with a novice crew. So it's kind of on the simpler side. As we move up to 41 to 55, this is kind of what we consider as kind of the minimum range for starting to do serious ocean passages. The Leopard series that we designed from 38 to 46, for a long time they delivered all the boats on their own bottoms from Cape Town to Europe or Cape Town to Bermuda. And at 41, 40 odd feet, there's enough payload, there's enough room, there's enough weight carrying capacity that if you're going to do an Atlantic crossing or you're going to do a Pacific crossing, you can pile on enough extra fuel and water and food and spare parts that you're not completely sinking the boat. Generally, a smaller boat just has less payload capacity, and generally a bigger boat has more payload capacity. And that's just the extra volume and gives you the extra space to put things like surfboards and wine and spare parts and shell collections and books and everything else that ends up on board when you actually go cruising. The next size up, 56 to 65. This is kind of the upper end of the range for what we think owner operator an experienced person, experienced guy and his wife or crew can basically handle as still being like not a full professional. 56 to 65 is generally a much more forgiving size out in the ocean. You know, the joke always is length is your friend out in the ocean, and every boat is better 10 feet longer. So we always like to, if the budget allows, stretch the boat. Even if we don't put something in the bow or the stern, the extra waterline length really helps dampen pitching. And dampening the pitching, the hobby horsing, is one of the most important things to providing comfort during a passage. And generally, we find the boats are much stronger than the people, so you're not going to slow down the boat because you're going to break the boat. You're going to slow the boat down because it's uncomfortable. And length is your friend, again, in the ocean. At 65 feet, you've got a big boat, and a big boat takes a fair amount of care and feeding. Just the daily ongoing maintenance of a 65-footer can keep one guy pretty much running around full time, just keeping it clean. Boats like to be used, so you really need to cycle the boat, especially these days with a lot of electronics on board and a lot of systems. If you leave your 65-foot boat dormant for 6 months, it's really hard on the boat. You know, the boats actually need use to keep in good shape. And generally, a boat on that upper range of 60, 65 feet needs someone on board to almost full time to keep it in tip-top shape. Once we go over 66 to 78 feet, we have some very experienced owners that can manage their 66-footers and 70-footers. But that's after they've come up through the ranks and spent a bit of time on smaller boats and got a handle on it. But living aboard 66 to 70-footer as a couple is possible with good experience. But any of you guys who've been aboard a boat for a long time know that eventually you have to be a jack of all trades. And you have to have a bit of knowledge about everything, and especially these days, electronics, to keep the thing operating. Once you get off away from cell phone service and FedEx delivery service, you're kind of on your own out in the South Pacific, especially still. And being able to fix your own boat is really important to keeping your itinerary intact and keeping your crews and your crew happy and keeping things moving. And generally, we see boats over 70 feet having a professional on board, a full-time skipper at least, and sometimes skipper and crew. Once we go over 78 feet, we're almost always in full time skipper mode, and a lot of times that's for insurance too. Once you get into the 55-foot range, we're finding insurance companies require more and more proof of experience, or requiring owners to sail with a licensed or an experienced captain for anywhere from 6 months to a year before they will sign off on letting the owner operator take control of his own boat without assistance. So depending on your boat and your location, sometimes you have to budget in that you might need to have a professional skipper on board for at least a limited amount of time to get the insurance to sign off. And generally, I think if we're going to put price tags on this, and I'd be talking new prices, 38 to 40 is still sub, $1 million US, easy. From 41 to 55. Most of our HH boats are pushing, 3 million. The 56 to 65, our HHs are pushing 4.5 million. And from 66, 78, our 77 footers are pushing 7 million. And then currently we've got an 88-foot boat under construction, and it's going to be 10 million. So it kind of jumps up by the cube of the weight. So here's some images of kind of typical boats in these size ranges that we've designed. That's a Leopard 38 in the upper left-hand corner, Leopard 44. This was a custom 52-footer Kiapa. It's actually down in New Zealand right now. This is a rendering of a HH66 that we designed that are built by HH in Xiamen, China. And there's 5 of those in the water now. And this is an example of a gunboat 90 that we designed. Here's a nice rendering or profile of a boat we've been looking at working with Rhodes and Young on. It's a 80-footer. This one has one of those forward cockpits that's just for crew lounging and goofing off. Now, and in fact, it's one of the most critical ratios that we feel is important is the underwing height. And that's the distance between the bottom of the underwing, the cross structure, and the water. And the way we quantify this is we take the BOC, which is the beam on center. So that's the center line of one hull to the center line of the other hull. And we like this underwing height to be about 14 to 15% of this width. Not the BOA, the beam overall is not what we're worried about. We're worried about what we call beam on center. And we like to see this number between 14 and 15 for a general ocean, comfortable boat. Now, if it's 13%, it's not the end of the world. If it's 11%, you're probably getting kind of low and you're going to start pounding the underwing sooner and sooner. More than 15, 16%, it's kind of a more the merrier. On a hard-pressed race boat, we might be as high as 17% or 18%, but we expect the boat to drive really, really hard. But somewhere in the 14 to 15% range is pretty reasonable. Now, there's a couple things to be aware of. Boat builders and designers are kind of sneaky. Sometimes they'll have the underwing quite, relatively high right at the front underneath the mast. But as the underwing goes aft, they might step it down or angle it down so it's much lower in the back, at the back beam. Or they'll do funny things like put shelves on the inboard side of the hull to create some extra space for the berths. And all these little protrusions or reductions in height just ask to be pounded first. And if you think about it, when a boat's going upwind and it's sailing at 45 degrees to the waves, it basically goes over on a diagonal. And what we always find is that the underwing going upwind will pound first on the leeward aft corner. So on our designs, we like the underwing to be basically horizontal, dead level to the world at rest. We don't like the underwing to be sloped down towards the stern. We like it to be straight level when the boat's at rest. In fact, we use that as a reference when we build the boat, that everyone knows that the boat is dead level when the underwing's dead level, both vertically and horizontally. And we actually judge mast rake off our underwing. So if you ever see me, sometimes I'll put a digital scale on the front of the mast to measure the mast rake, and then I'll put the digital scale on the underwing inside the cabin. And the relationship between the two is the mast rake. And we're always making sure the mast rake is proper so that the helm is balanced. But this is what we consider one of the more critical parameters. The other thing you'll see quite frequently in production multi-hulls especially is what we call immersed transoms. And we, as a design group, mainly because of our racing background, we really prefer to have what we call transom clearance. So that's the distance from the water at rest to the back of the very bottom tippy tip of the transom. And we like that to be out of the water at rest. There's a few reasons. You know, a catamaran, when it sails, as it gets powered up, you know, the weather hull lifts up and the leeward hull sinks down. And if you start off with your transom underwater to start with at rest, it's super draggy, and it's like dragging buckets behind the boat. And we know from small cat racing experience and pretty much any catamaran racing experience, in light air, we actually bow load the boat to get the stern out as much as possible. Because when the stern digs down as you're pitching through any sort of wave, it creates basically a backflow and a turbulence, and you can tell by the noise if it's dragging. Now, there's certain signs that a boat is overweight or it's heavier than the designer intended because the transom is underwater at rest. And this is not too infrequent depending on the generation of multihull. There was a lot of optimism, you know, back in the 90s and the early 2000s about, you know, what these boats weighed when they were being designed. But by the time they got built and they got loaded and they got sailed, you know, they just sank at the dock, right? As people put on, you know, these, depending on the size of the boat, you know, these boats will sink about 1 inch, like a typical 50 HH55 sinks about 1 inch for every 2,000 pounds you put on it. And if you started off with 2 inches of transom clearance and you put 2 tons on it, then the transom is at the waterline. We like to design our boats so that when they're fully loaded with what we call our max displacement, you still have at least, you know, 2 inches of the transom out of the water at rest. And it's not a horrible, you know, deal-killing, you know, issue if the transom's underwater. What it does do, though, is it really hampers your light air sailing ability until you're going fast enough that the water can sheen off the back of the boat nice and clear and not tumble on top of itself. You're not going fast enough. And if the boat has an immersed transom at rest, it may never clear out. You can't go fast enough to get it to clear out. Typically, overweight issues are a factor of all three groups. The designer was too optimistic. The builder either didn't follow the plans, or he piled on more weight because if a little's good, a lot's better. The builder and the designer didn't agree on how the boat was going to get built. I mean, sometimes designers will think, well, I'm going to specify that they use foam for the bulkheads, and the builder chooses to use plywood to save money. But he pounds in an extra 1,000 pounds. So there's got to be a good agreement between the boat builder and the designers about how we're building the boat so the boat comes out on weight. Then the owner has responsibility too. Generally, you know, when we are designing a boat for anyone, whether it's a custom or production, we have these design meetings where we basically decide, you know, what's going on this thing, how many toys, how much wine, you know, how many books, how big's the dinghy, where's the dinghy, is the dinghy on the davit, you know, do we want, as you can see in this photo, it's got the dinghy with a, you know, 25 horse engine sitting on it, and it still has transom clearance. A lot of times designers will forget about the dinghy or forget about the davits and design the boat. All's well and good till they put that 500-pound tender on the back of the boat with, you know, 150 pounds of davits. And then the boat starts to pull a wheelie as it sits down on its stern. And catamarans are sensitive to weight in the stern because it's easier to store stuff after the mast than in front of the mast. So generally everything that comes on board after the boat's built goes after the mast because it's easier to get to. So we have a tendency to try to build the boats with sufficient transom clearance at the start so that even if the owner is a bit over exuberant about loading up cases of wine, the transoms don't go underwater. One of the other things you'll have a choice, especially these days as sail makers have gotten more bold with their mainsail design, is what we call square top mainsails or fatheads. And traditionally, what we now refer to as pinheads is a conventional roached mainsail on a catamaran usually had a smaller headboard. And as sailcloth technology improved, it was possible to build these what we call gaff battens and fathead mainsails. And in doing so, you can increase the sail area on the same size mast, between 5 and 6%. Now that doesn't sound like a lot of sail area, but it's all up high. And it reduces the shape of the top of the sail is much more aerodynamic. So we have a lot less what we call tip loss, vortexes, flipping off the top. And so you can get a lot of bang for the buck. You might only be adding 5 or 6% sail area, but you might be getting 10% more power. So it's a really kind of cheap way to increase the power on any number of boats these days. And as almost a standard now, we specify the size of the fathead, we specify as a percentage of the length of the boom. So in this case, this distance up here at the top is about 35% of the length of the boom. And that's considered by today's standard, that's considered kind of a medium generous fathead. Now we've done as much as 45% fatheads on gunboat 66s and more performance-oriented boats. There's a couple issues. As the fatheads get bigger, they're good until you have to reef, and then once you start having to reef, the benefit of the fathead starts to diminish. If you sail in a light air location like where I live in Newport Beach in California, or maybe in the Chesapeake, where it's predominantly light air, a fathead's a good idea. If you live in Hawaii or you live in high trade wind conditions where you typically are sailing with a single reef a lot, a big fathead might be a waste of money. Maybe something closer to 15% or 20% fathead would be more appropriate if you're in a windy area. But if you're looking for a lot of light air performance, and especially downwind, a fathead's a lot of bang for the buck, and the incremental cost is, I think, well worth it. One of the couple of issues with fatheads, though, is because this gaff batten doesn't like to fold up inside the sail bag at all, we have to have what we call detachable headboard cars. So there's a number of systems on the market. Anomaly is one of the better known ones that allow the mainsail to be raised, and it hooks the headboard car as you're raising it. And then as you're lowering it, it unhooks the headboard car so the gaff batten can fold down flat inside your sail bag. Without it, you have this chunk of sail that could be possibly as like 6 or 8 feet, 4.5 wide and 4 foot tall. And it's almost impossible to get a sail bag over it. So the requirement to have some sort of detachable headboard car comes with a fathead. The other issue is that because you do have what essentially is a gaff, this batten and compression, is the cars on the track have to be usually beefed up because you have a lot more batten compression. And so long as the mast builder and the sailmaker all talk and organize themselves during the process, it's usually not an issue. But it is very important to make sure the sailmakers understand and realize that you're going to use a detachable headboard and you want it to fold flat inside your sail bag. Otherwise, you can have all kinds of weird stretches, stretching the cloth really badly up here at the gaff when it's trying to fold down inside the sail bag. Now, one of the other choices you're going to have looking around through, kind of the production series boats are the choice between mini keels and dagger boards. Now, we do both. Both have their pros and cons. Most manufacturers prefer mini keels. One, because they're a hell of a lot cheaper. They're a hell of a lot less warranty. And they're almost idiot-proof to, build, install, sail with. You really can't, damage them. I mean, you can run them into rocks and maybe you knock the crap out of them, but you don't violate the watertight integrity of the boat. The draft is lower all the time. It's the dagger boards, on the other hand, are more expensive, more fragile. The benefit, though, is they provide better upwind performance. And if you have a performance boat like an HH or a gunboat, they actually provide better performance downwind, because on like a Leopard 44, going downwind, if it's blowing 20 and you're going downwind at 150 true wind angle or 155 true wind angle, the apparent wind is still behind the beam. The apparent wind's only, probably 110 or 120. Where on a faster boat, even going downwind at 155 true wind angle, the apparent wind might be at 90, or even ahead of 90, it might be at 80. So the boat still thinks it's going upwind. And in that case, the dagger board is still way more efficient, even downwind, when you might have thought otherwise. You might thought, oh, well, we'll just raise the boards downwind. Well, on a fast cruising multi-hull these days, the apparent wind rarely goes aft of 90 degrees apparent, unless it's blowing like 35 and you're just trying to go downwind safely, and then the apparent goes aft. But typically in 12 to 0 to 18 knots, the apparent wind is always forward of the beam on a kind of performance-oriented boat. Now, there are dagger board production boats, and some of the dagger board production boats are worse than the mini keel boats, partially because the dagger boards aren't built strong enough, long enough, and thin enough to do a good job. A good mini keel boat can actually go faster than a bad dagger board boat. It's a bit of a issue with production manufacturers trying to build dagger boards, because dagger boards are super highly loaded and expensive. Like on a gunboat 55, I'm sorry, on a HH 55 or an HH 66, a replacement dagger board is $90,000 to $100,000. Knock on wood, we haven't broken one, but if you manage to hit a rock hard enough, you probably will break one. And most production companies are so sensitive to cost that they really don't want to offer dagger boards because of the increased cost of building the boards, the dagger cases, the bearings, the lifting system, all add to cost. For what might just be an incremental increase in performance for the average, guy cruising. So it's a bit of horses for courses. And if you're looking for lower maintenance, simplicity, lower cost, a good dagger board, a good mini keel boat is just fine. Your difference in speed over a delivery of 10 days might be, half a day. If it's upwind, it might be a day. If it's reaching or downwind, it might be half a day. we do a lot of extensive velocity prediction program work where we can estimate the speed of the boat. And we've done trade studies frequently with dagger boards and mini keels. And actually in certain conditions, dagger boards are not buying you a whole lot. Like downwind and heavy air, there's not a lot of delta. But upwind and light air and upwind reaching and fast boats going downwind, there's a delta of as much as 4 or 5% VMG, velocity made good, which can be the difference in arriving at sunset and arriving at midnight. So it's something to consider. These days, you don't see galley down as much as you see galley up. And this is where, generally we discuss, you put the kitchen, the stove, the sink, trash cans, dishwashers, refrigerators, everything you own up in the bridge deck. This is a Leopard 44, very typical of a lot of production boats. The benefit is that better visibility for people cooking, better access to bring food outside or bring food inside, better ventilation, better lighting. It does eat up a chunk of the interior, but the trade-off generally, as people vote with their wallet, is most production series boats have galley up. Now, the alternative is what we call galley down. And this was a custom 46-footer we designed a few years back. And it was an experienced husband and wife cruising couple. And they live aboard. I think this boat is now, if it's 15, it's 18 years old. And they've been living aboard since. And the husband-wife combo, she's really an amateur chef, and she loves to experiment and cook. And if you ever go cruising, there's two subjects you always talk about. One is anchoring. There's three. There's anchoring, there's heads, and there's food. And it becomes a real cruising staple to go to different locations and share meals. And from their experience, they didn't want to have her half-baked experiments always out on the counter. So she wanted more galley, more counter space, and preferred galley down so she could hide the dirty dishes and still bring friends over and have cocktail in the evening and not have to interrupt her gourmet experiments that were going on in the galley. And the benefit is you can get a huge amount of counter space. This boat was basically a 2-cabin boat, 46-footer, had a master cabin on the port side and had a guest cabin aft on starboard. But most of the starboard hull was dedicated to galley. And they loved it. Now, as we've moved through
Still there? Okay, good. As we've moved through development over the last 20 odd years, our hull shapes have changed significantly. In this picture, you can see our Generation 1 hull was what we considered our gunboat 60. This happens to be a 66, but a 62, 66. In 2002, and then Generation 2, we started changing to a slightly different shape. Then Generation 3 occurred a few years later, and currently we're in what we call Generation 4. And what we see is generally we've gone from more conventional plumb bows, where the bow is essentially vertical in profile, to more and more aft rake. And this aft rake is not just an aesthetic, trick. It really has a reason. And what we're looking at is if you took a cross section through the bow about 1.5 meters or 4 odd feet after the bow, a generation one looked fairly conventional to everyone's eye. It was kind of V elliptical. It was kind of wider towards the deck and skinnier at the bottom. Over the time as we've been racing and developing and looking at improving or reducing pitching on sailboats, we started to evolve to what we called generation two, which started to get a little bit fuller at the bottom and a little bit more tumble home. That's what we call that kind of where it's wider in the middle and skinnier at the deck. And generation three has gone a step further. And if you can see on this image on the lower right, where we overlay generation 1, 2, and 3, you can see how the boat's gotten more displacement, more volume underwater, lower. And we've reduced the displacement and the volume above the waterline. And the net effect is that as the boat is traveling through waves, it pitches up less as it encounters the wave, and then it pitches down less as it exits the wave. And the fact that the boat's pitching a little less helps because the transom isn't dragging, the underwing isn't hitting, but the biggest benefit is up at the top of the rig at 60 or 70 feet tall. Instead of the mast going through a 10 or 12-foot arc as you pitch through the waves going upwind, it reduced that arc by 2 or 3 feet or 20 or 30%. So the net result was that we got more efficient power out of the sails since the rig wasn't slamming back and forth at the top. And so for a race boat, it was like free energy. The boats went faster. And so we started adopting that concept to our cruising cats. And actually, if you look around, there's quite a few monohull powerboats that have adopted the same thing. Now, the benefit to a power catamaran or a power monohull is if the boat pitches less, then the thrust out of the propeller is pointed aft more than is pointed down or up. So you get the benefit of more efficient propulsion for the same amount of horsepower. None of this is new. The Alouette Indians, had this figured out about 4 BC, I think, and it took us only 2,000 odd years to kind of circle around and reclaim the idea as something new. But we have a tendency to push this further and further on race boats, but we've now decided there's a limit to how far you can go, because as the boat got fuller and fuller forward, it started to have a problem with pounding upwind, because that forward 1/3 of the boat was getting too flat, which is fine if you're an America's Cup race boat, or you're crazy guy sailing with your hair on fire all the time. But if you're cruising around with both hulls in the water all the time, we found what we think is a good compromise between going too far in this direction and settling into a shape that is what we call more sea kindly. It doesn't pound upwind. And what's interesting about catamarans when they're going relatively fast upwind is that we're not worried about the leeward hull pounding, we're worried about the weather hull pounding. Because the leeward hull is like immersed, is pushed down in the water because of the sail pressure heeling over. But the weather hull starts to lift, and instead of the bow of the boat going through the wave, it's 1/3 aft, or the middle of the boat is what's starting to go through the waves. And that's where you get the annoying pounding. So we kind of dial back and forth on this sea kindliness, mid-hull shape, depending on what the customer, what the client, wants. Is it more interested in flat out performance, or more interested in a good compromise, or interested in I don't want to pound ever. And you end up with a lot softer, more V-shaped, elliptical shaped underbody. But the net result is for the same sail power, the boats sail sometimes between 8 and 10% faster with the new hull shapes. And it's not because the hull is 10% slippier, it's because the rig is working better as well. And what drives the forward rake, the look, is because as the water lines come together at the bow, since it's fatter at the bottom, they come together further forward. And up at the deck where it's skinnier, they come together later. So in profile, that's what produces that aft wave piercy, aft rake kind of look. Now, there are certain manufacturers out there trying to kind of get on the bandwagon, and they're actually modifying existing hulls and existing molds to make them look like they're wave piercing, because it's kind of trendy right now. But in reality, all they did was kind of put big hollows in the deck and kind of fake it to make it look like that. And it's not truly designed from scratch as what we would call a wave piercing shape. One of the other multitude of choices you get with catamarans is, where to drive from. Up in the upper left-hand corner, this is a 65-footer called Multihull, and it was a dual wheel, had a solid bimini all the way across the cockpit, and it had most of the jib and sail controls at the helm or piled up here on the back beam. This is a fairly user-friendly steer from weather kind of system. This hatch, there was a hatch above here that you could stick your head out, or you could sit on the seat and close the hatch. So it had kind of decent all-weather protection with isinglass on the sides if you wanted. This one happened to have a front windshield that would open up like a safari window, or like on an old Volkswagen van. And it's a fairly good compromise. Now, this image on the right is typical of one of our gunboats. This happens to be a gunboat 90, so it's kind of big and spacious. But the idea is that the helm is right behind the mast, right at the forward end of the cabin. And we've done a number of 18 of the gunboats like this, where it's basically forward helm, and you have two doors, one on either side, that give you access to a forward cockpit. And that's where all the halyards, sail controls are, reef lines, anchor windlass, basically everything an owner-operator might want to be close at hand to. And the original premise of the gunboat forward cockpit was owner-operators. And if you know the history of that line a little bit, Peter Johnstone, being from Newport, Rhode Island, sailed a lot in the fog and cold air, cold wind up there, and wanted to be able to be inside sailing. So he basically forego an outside cockpit completely, and the only helm was inside, and you had doors to the forward cockpit. And the idea being that when it's nice, you can sail with the doors open. When it's nasty, you can sail with typically you'd sail with the leeward door shut and the weather door open, because the spray would have a tendency to go to the leeward side. You had great visibility forward, and you also were in the comfort of the interior. So it was warm, it was dry, galley was right next to you, the nav station was right next to you. Made a lot of sense. I mean, we built 25 of these over the last 18 years, just for that reason. Because for an owner operator, it gives you the chance to basically control a much bigger boat with a lot less real estate to run around in, compared to a dual helm boat where you're going to have to cross the cockpit when you jibe and tack. You could have blind spots with the main and jib to leeward, where with a forward helm boat you can see, basically 360 degrees. But some of the downsides are windows at night are hard to look out of. If you had Portuguese windows where they were all forward facing, you could get rid of some of the glare, but then it's kind of not very attractive. Windows have a tendency to get water spots on them, especially salt. And so, you send out your crew or somebody has to go out there and wash the front windows every couple hours sometimes because the salt builds up and you can't see through the windows anymore. So there's pros and cons. We recently did designed a boat called an HH66 called Flash. And it had a single inside steering station like this, but it also had dual bucket seats and tillers aft. And we were able to put most of the sail controls back on both helm seats because it was a hydraulic main sheet, line drivers for travelers. And when it was nice, you could go sit in the back of the boat and see the sails, feel the apparent wind. Super comfortable, great for Caribbean, great for going to Hawaii. If it was nasty, he could always go inside and use the inside helm. And if it was nice, he could steer from the outside. And conventionally, they always do day sailing and racing from the outside, and they do deliveries from the inside. We're not worried about performance sailing as much, because one of the bigger problems with inside steering is a complete lack of apparent wind. You open the door and the wind's coming through the door. So you really don't know if the apparent wind's moving aft, or you also lose some of the sensation of speed. When you're always inside, you don't feel the boat heel over very much because you're in the middle, and you don't feel it pitching as much because you're right in the middle, which is good for sea kindliness. But if you're trying to sail the boat efficiently and more in a performance mode, you really miss, especially if you grew up sailing, you really miss apparent wind, the wind on your face, the noises, the view of the sails, the trim. It's much easier when you're outside. When you're inside and you're looking through windows, it's a bit of a compromise. So all that combines to kind of a horses for courses, or you can do a hybrid and have your cake and eat it too. Have inside helm and outside bucket seats and tillers. One of the fallouts from the gunboats that we discovered that everyone liked, though, was this forward cockpit. Now, this happens to be a Leopard 44 that we first tried it out on in a production cruising boat. And this forward cockpit had no sail controls, no winches, everything still led aft very conventionally. But what we were challenged by was over the years, as the moorings chartered more and more bigger and bigger cats, they found that the increase in air conditioning was becoming a bigger cost driver for diesel consumption than the engines, because people were running the gensets, basically all day long to keep the interior cool. So they asked us to come up with some better ways to have passive ventilation. And so we proposed basically doing a forward cockpit with this big front door, because once you open the front door up, you can have a small hurricane blowing through the boat if you want. And what we found as the boats were being used and adapted is the genset use went down by like 30%, because there was so much passive ventilation through the front door that people didn't feel necessary to turn on the air conditioning till much, much later in the day or in the evening when it got hot and there was no wind. But during the day, when there was any amount of breeze, they'd have the front door open and they'd get this great amount of passive ventilation. And for the charter boat community, they're always looking for like a little bit of ways to separate the family. So you could have a front cockpit, you could have a back cockpit, you could have the salon, and you could have the accommodation areas. And so it became pretty popular, and Robertson Kane has pretty much adopted it to all their models nowadays. So it doesn't, we were, because we've had, we had a dozen years of gunboat experience prior to, putting it on the first Leopard. We found that, the first question people always go, well, does it fill up with water? What about waves, breaking in the front windows? And the boats are all designed to ISO EC specifications, which determine how thick all this is, how strong all the windows are. And in a forward cockpit, how fast it drains. And there's a lot of, building codes, ISO EC specs that mandate all this stuff. And we adhere and exceed most of them. But we rarely have anything remotely solid coming into one of these. You might get spray from wave tops coming into this, but nothing like a solid green chunk of water. The boats are just, especially a Leopard 44, has got too much freeboard. Mast is far enough aft. The trampolines always dampen the waves as they try to break through and onto the deck. And we've never really had an issue. One of the questions I think I probably answer this question weekly with new prospects, new clients wanting to try to green up their life and green up their boat is using diesel electric hybrids. It's becoming better. The entire system of the entire system of batteries, chargers, motors, battery control systems, up till now has not been you've not been able to buy it from one company. And most of the hybrid systems that we've been involved with end up with something like 35 subcontractors. And the trouble is they all end up pointing at each other when something doesn't go right. It's, the software guys blaming the hardware guys, or there are slight incompatibilities between products. And the results to date have been spotty. Now, two companies, Torqeedo as one predominantly is trying to, and Mastervolt are trying to put together what we call the soup to nuts solution. So under one warranty phone call, they will be responsible for everything from batteries to battery management to chargers to integrating to your solar panels to integrating to your shore power to integrating with the generators that you still have on your propulsion engines. And it's getting closer to I think a reliable system, because the boat builders, we don't build 250,000 of anything a year. It's not like a Prius or a Tesla, where the manufacturers can vet their systems over hundreds of miles and miles of train or of testing before they bring it out to the public. Generally, unfortunately, production boat building and custom boat building, everybody's a beta tester when something new comes out. And to date, the reliability of a full diesel hybrid electric system working straight out of the box is very low. If I had to say today what I would choose, lithium batteries for sure, solar panels for sure. Most of the smart charging is working, but the siren song of silent motoring comes at a big penalty in terms of cost and weight. And to date, neither of those two variables, cost and weight, have been beaten by simple diesel sail drives or diesel props and shafts. And if you're in Timbuktu and Fiji, good luck getting your hybrid diesel electric system serviced from Germany or Sweden. It's still not as reliable as a Yanmar or a Volvo, where you can still walk into a lot of third world countries and find parts. It's still a bit of horses for courses. If you're sticking coastal, East Coast, West Coast, med where you're within DHL and FedEx range and you got good cell phone coverage, yeah, it's probably worth a try. I mean, we've got 2 projects right now that are full hybrid electric diesels, but both owners have been through this once already and know what they're getting into. So it's a bit of buyer beware. I'm really hoping Torqeedo or Mastervolt, can produce and warrant a fully reliable system. But if I had to make a choice today, I would still probably back off on the full commitment. That being said, hydro generators and solar panels are getting better and better, cheaper, more reliable. We're big fans of Watt&C, the hydro generator manufacturer, and we use a lot of Solbion panels from Italy. We're very happy with those, and we're learning how to wire them and how important it is to have individual control units for individual panels to be able to deal with the shade, especially on a sailboat, of the rig and the boom over the panels. But the output of a boat with somewhere between 2.5 and 3,000 kW of solar panel is enough to keep a decent 55, 65 foot boat operating without a genset for everything but air conditioning. Air conditioning is still hard to do if you're trying to air con an entire boat. Now, we've done several boats now where we'll build the boat with a small DC air conditioner just for the master cabin. And in fact, we'll put like curtains at the foot of the berth and make sure and put the air con directly under the berth. So at night, you can have 12 volt DC air con just in your berth, which if you're cruising, that's all, it's a couple. That's all you really need to cool down is the place where you're sleeping. You don't need to cool down the entire, hull or salon or, the guests if there's no guests there. And then you can get pretty easily 8 hours of air con overnight without bottoming out your lithium batteries. So it's kind of a hybrid of AC units, alternating current units, and DC current units in the same boat. And you just turn on the DCs at night when you're at anchor or in a marina where you don't have enough passive ventilation to keep the boat cool, or it's just too hot. This is an example of one of the boats we're designing right now. It's a HH77. This boat will have a fly bridge, dual helm, dagger boards, carbon fiber. This will be about a $7 million boat. And this is my last image, and I'll take some questions after this as time permits. This happens to be one of my favorite boats. This is R6. It's a HH 6601 sitting off Malta. And always love the gorgeous water. So I'm going to get off the share and turn this back over to Alex.
Well, thank you, Gino. This was a really great presentation. So I have a couple of questions, but we'll take the ones that have already been put into the chat. So there was a question about, could you comment on the I guess maybe the difference in daggerboard shape, if there is any, between the new gunboats and the new HH?
Sure. Depending on which one. The bigger question typically is asymmetric shapes versus symmetric shapes. And the current HH66 stock boats have curved C symmetric daggerboards. And at 20 knots, they'll provide about what we call a 15% lift fraction. So the leeward board at 20 knots can lift the entire boat up about 20% of its weight. An asymmetric board of roughly the same size will lift about another 10 or 15%. So an asymmetric shape gives you more lift for the same drag. And that's a benefit for most of the time, but there's a bunch of things you have to consider. An asymmetric shape, because you have two of them, one on each side, you can't sail with the weatherboard down because it's opposing the leeward board. So generally you have to raise the weatherboard, and that requires you to make the leeward board even bigger, because in light air on a symmetric board boat, we sail with both boards down until we're almost at hull fly, and then we raise the weatherboard. But on an asymmetric boat, you have to have a bigger board to start with because you don't have the benefit of its buddy over on the other hull. The other problem or compromise is typically when you raise your board, you want to raise it flush with the bottom of the boat, the asymmetric. And by doing so, you get rid of the drag, but you also leave your sail drive and your rudder exposed to damage. Typically on a symmetric boat, we always leave about 3 feet of board sticking down below the bottom of the boat when the board's in its normal raised position, because the dagger board provides protection for the rudder and the sail drive. And if you have an asymmetric dagger board, because it's longer, you have to have a gantry. It's like a contraption to lift the board much higher than the deck. And these gantries either raise and lower or they're fixed. And so you have a bunch more mechanics and cost to deal with this all. The upside is they're faster. It's another 3%, 2% faster upwind VMG, which if you're racing, 2% is worth something. So it's a bit of a trade-off. The other trade typically is one of the reasons we do seaboards, where the boards have a constant radius, is it keeps the board out of the accommodation of the boat. It almost mirrors the shape of the boat on the outboard topside. So we can tuck the boards tight up against the side of the boat and not intrude into the middle of the boat. If you've got a straight dagger board, it more than likely intrudes into the interior. So the curved Cs help us keep the accommodation space a little bit more clear of the dagger board. So those are all various compromises and advantages.
Okay, so 2 questions about hobby horsing. One is, can you talk a little bit about what really causes the hobby horsing?
Well, the main cause is weights. As the boat sails along and encounters, a wave, it's got to raise over it. And as it starts to lift over it, as it passes the wave, and if the wave's moving at 18 knots and you're moving at 12 knots, you have a counter speed of 20 knots. So the boat jumps out of the water. And once the boat starts to lift, you get this giant mass, which might be 17 to 20 tons starting to move. And as the wave passes, it has to go the other direction as the wave goes out. So this giant amount of energy causes hobby horsing, pitching. And if you can keep the mass from accelerating as it goes into the wave, then you don't have to dampen it on the back end. Now, sail force, basically you're pushing, I like to say, sailing, you're not getting pushed, you're getting sucked upwind. So the drive force is really high. It's not like a propeller at the back of the boat pushing the boat. It's literally you're getting sucked upwind or forward from 40 or 50% up. And because you're pulling the boat from really high up, it has a tendency to make the boat pitch. So you combine those two forces together and you get quite a pitch moment going. So all the things that we talked about earlier, trying to reduce that pitch moment by reducing the amount the rig starts to oscillate and the amount the boat starts to pitch.
And you mentioned early on that you've been doing some things with foils to help dampen the pitching.
Yeah, what we find because the curved Cs are providing lift forward to the center of gravity, they actually almost set up the boat so it's sitting up, it pushes down a little bit on its transits. And when the boat goes through the wave, it almost has like a balancing force already. And when the boat comes off it, the curved seas actually dampen the boat. If it's a straight vertical dagger board and it's pitching, it basically goes up and down. It doesn't resist at all. But if it's, let's see if I can show it like this. If it's curved, when the board goes down, it actually develops lift, and that helps reduce the pitching effect. We get pretty carried away all the way to the point of trying to lift the boat entirely, like the America's Cup boats or race boats. And then you basically eliminate the hull completely from pitching because it's in the air. And our joke is that the hulls become foil delivery devices because they really aren't doing anything but delivering the foils to the water. So that's the extreme of that.
Okay, and on a maybe slightly more practical perspective, you're talking about payload capacity. Is there a way of figuring out, when is too much without looking at the water line?
Typically, a production boat built in Europe or South Africa, they are required by ISO, the building codes that the boats have to be designed and built to and certified to be able to be sold in Europe. They require a max displacement declaration when you build the boat. So you have what we call ISO lightship, and then you have ISO max displacement. And that max displacement number is what all the engineering calculations are based on. So you could theoretically go to your manufacturer and say, what is my max disp? What's my max displacement? And they know that number. Whether they'll tell you or not may be subjective, but they know that number because they had to submit it to get the boat approved by ISO. And generally, it's the delta between the lightship and the max displacement that encompasses all that you can put on the boat. And sometimes what you'll see is, in fact, we do this regularly with HHs, is when you go through buying the boat, there's a lightship displacement, and it lists everything on board that comes with lightship displacement. And ISO actually has a rule for it, that what's defined as lightship. Because in the past, boat manufacturers used to tell, oh, my boat weighs 13 tons, but it doesn't include the mast and the sails and the anchors and the chain and, sometimes not even the interior furniture. But there's actually an ISO definition of lightship. And so the delta between lightship and max disp is your payload. And that's what you get to burn up with options. Like if you put a bigger TV on board, or you put bigger anchors, or you put more equipment or bigger winches, your lightship might go up and get closer and closer to your max displacement. And you basically burn up your payload with options. And you have to be careful that, if you put every option known to man onto your boat, you might not have any room for wine. There's going to be a certain amount of room left that you have for discretionary loading. So it's important to know what lightship is and max displacement is.
And then for calculation purposes, if you know what your lightship and max is, and you put a 300-pound generator on, you just add the 300 to your light to see where it takes you.
Yeah, and what you got left is what you got left. Now, once you get to max disp, that doesn't mean that's the end of the world. That means that you're now eating into your safety factors, because the rig was designed for a safety factor of 2 point something. And as you go over max displacement, all your safety factors start getting eaten into.
Okay, so we have two other questions. One was, what's the approximate cost to design a 48-foot performance cruising daggerboard catamaran?
If it's a custom one-off, typically that might be for us, depending on the builder, et cetera, it'd probably be $150,000 or so. Depends on builders. There's a big variation. If we work with a builder and we know them and we've worked with them in the past, we typically have to provide a lot less information. If it's a builder who has access to 5-axis CNC these days, we have to provide a lot less information. If it's a builder who's a little bit more old school, then we have to provide a lot more drawings, or they're a little more inexperienced, we have to provide a lot more drawings. So depending on the builder, our what we call our scope of work could vary by 25% or 50%.
Okay, and I think this will be the last question. So when do you think foiling cruising cats are going to be ready for prime time?
I guess it depends on your definition of cruising. Fully flying, foiling. We've got a pretty extreme one coming down the road here, but I don't know if I define it. It's still going to have a galley and refrigerators and four cabins and electric toilets, but it's going to be pretty austere otherwise. As a 72 footer, it's going to have the interior of about a 55, 60 footer. But it's a $10 million boat. So I don't know. There's, trouble with flying is like an airplane, if it weighs something, we got to lift it out of the water. And that costs a lot of energy and typically costs a lot of money to get rid of that weight. I don't think we're going to see flying boats, but we will see boats with what we call higher lift fractions. Like right now, the stock HHs have about 15%, but the next generation, will probably up it to 20, 25% lift fractions as we're becoming more comfortable with providing adjustable T rudders on stock catamarans. And they start to pick up, 4 or 5% of the lift fraction. So, and also dampen pitching.
Okay, well, we've gotten a lot of compliments and thank yous to you. And this has been a really great chat. So I think with that, I will turn it back to Barb and we'll call it a wrap. Thank you, Gino.
Great. Thanks, Alex.
All right, thanks, Alex. And thank you so much, Gino. A lot of great information. I can see by the chat box that people really appreciated the information that you shared today. So thank you.
You're welcome. And if anyone has a burning question, they can always email me directly. I think my contacts are probably somewhere around.
Okay, and I can include it when I send out the link to the recording. So if anyone has any additional questions, you'll be able to go ahead and contact Gino. All right. Well, thank you everyone for attending today. We have another great webinar on tap on Thursday. It's one of our panel discussions, which are always full of a lot of great information. And this one is on our favorite dinghy. So hope you'll join us on Thursday. Thanks, everyone.
Thanks a lot.
Thanks, Gino. Take care.